Okay, so, well, my wife is not home yet, and so I feel somehow like it would be morally wrong of me to eat the pizza or to start the pizza before she gets home, since she, ordered it and paid for it and all. So I am going to just do problem 8 because I'm here. So we have this position versus time graph for some object, and we want to answer these questions. Now, this is different from a velocity versus time graph, of course, because it shows position instead of velocity. So be prepared for any kind of plot to show up and know how you would handle each one. Don't just memorize what you do for a velocity plot and then do that blindly when you get a plot, because then you might get things wrong. So for example, what's the average velocity of the object between 2 seconds and 10 seconds? So let's start. How do we find average velocity? We've got a position versus time plot here, and if you remember how this goes with the little ladder, here's a position versus time plot, and here's a velocity versus time plot that matches. And if we want to go down from position to velocity, we take the slope. Okay, so to get average velocity of the object between 2 seconds and 10 seconds, we are going to take the slope of something. Okay, as it so happens, we're given two different points to look at, 2 seconds and 10 seconds. And that's your little key. Since you're looking for average velocity, you're looking over a region. And so you want to look for what happens in 2 seconds and 10 seconds. Okay? And then you pretend there's a line between them. And I'm not going to, well, I'll sort of dash it in. Okay? So this is our line. Pretend that's a straight line. Okay? And we want to find the slope of that. So the slope is going to be our average velocity. Okay, so and slope, remember, is rise over run. So in this case, the rise is your vertical change or your change in position. And so what this will get you, this is your displacement. Remember, change in position over change in time. Okay, hi. That's my wife, so I'm just going to finish this and then eat pizza that I've been waiting to eat. So the change in position between 2 and 10 is you finish at, let's see, 10 seconds looks like you're maybe at, like, I don't know, 2.4, okay, meters. So 2.4 is your final, and then you subtract your initial, which was 7 meters, 7.0, right at this point here, and then change in time was 8 seconds, so 8.0 seconds, and this was meters here. So 2.4 minus 7.0 gives you negative 4.6 meters. So this is going to be negative 4.6 meters over 8.0 seconds. And that gets you, let's see, what's that going to be? Half 0.56 meters per second, roughly. And it's negative, so negative 0.56 meters per second. Okay, 0.56. That's the worst handwriting ever, but I'm getting hungry. Okay, instantaneous velocity of the object at 13 seconds. Now again, we use slope. Actually, I'm going to do part B in blue. Again, we use slope. The difference here is we're only given 1 point in time. And so your little trick there is to remember, well, if you're given 1 point on the curve, the only kind of line we can draw there is a tangent. So you sort of have to just eyeball a tangent. Like I said, if you get the problem like this on a test, you just, well, don't draw it that badly, but you just sort of try to get in any reasonable looking line you can, let's see, and take the slope of it. In this case, the slope of this would be, I don't know, let's see, that point there is probably about 12 and 3, so we take delta x over delta t, and so I'm going to go from 12 up to, we'll call it 14. So my delta t is going to be 2 seconds horizontally, and then my vertical is going to be from 3.0 meters up to roughly 6.0 meters. So I'm going to go 3.0 meters. So this is going to be about positive 1.5 meters per second. Again, you don't have to be super precise when you're eyeballing it. Okay, the displacement from 9 seconds to 17 seconds, part C. You start here at 9 seconds with a 2 meter position, and 17 seconds you end up with right up there, which I would call like 8.4. Okay, So for C, displacement is final position, 8.4 meters, minus initial position, which was 2.0 meters, is going to be about 6.4 meters. Okay, let's see. What's another color I can use? Purple. Purple for D. At what times was the instantaneous velocity of the object 0? So remember, slope is velocity on position time plot. So you're looking for the points where you have a 0 slope or horizontal. And that looks to be right about at 9 seconds and right about 17 seconds. So 9 seconds, 17 seconds, I guess it should be 0.0 or not, whatever. And then what is the total distance traveled? This is tricky. Okay, so I'll do this in brown. Yeah, why not brown? Because brown's a tricky color. Okay, so total distance traveled during the time shown. This is tricky because, remember, displacement, when you're moving towards negative x, you get negative displacement. When you're moving towards positive x, you get positive displacement. So as you're going from here, say, down to here and then back up, you are unwinding some of your displacement. So you can't just find the displacement. You've got to find the distance. And displacement, well, the magnitude of displacement will be distance as long as you don't double back. So what you need to do here is say, look, you start at 10 and then you go down to 2. So first you go through a displacement of negative 8 meters, but that's really 8 meters. So here, from here to here, you travel roughly, I'm going to call this stretch 1. Distance for 1 is 10 down to 2 is 8 meters. Okay, and then starting here and coming back up to here, you come back up, looks like I'm going to go with like 6.4 meters. Okay, and then to get from here down to here, I would call that, you're going down 2, maybe 3 meters. Okay, 3.0 meters. This is all very rough. So that's your, well, I said D1 was 8 meters, and then D2, like if this is 2 and this is 3, this would be D2 equals this, and D3 equals this. So the total D is the sum of all these. I'm just going to write sum of D, and that is going to be here, let's call it 17.4 meters, okay, give or take. That's tricky. I don't think we'd have anything like that in the test, but if we do, you'll know how to do it. Anyway, that's the end of the review sheet, and I'm going to go eat some pizza and spend time with my lovely, lovely wife. So good luck reviewing, and I will see you sometime in the future.